6.5 volumes of pyramids and cones. So in this lesson, well, what we're going to be doing is, well, moving on from surface area to volumes, right? And remember what I mean by volumes. Volume is like the amount of stuff that you have inside, let's say like a box, right? So quite often we have a rectangular prism of some kind. And when I say what's the volume, I mean like how much stuff can the box hold? So instead of us adding all the faces together for the surface area, what we're going to be doing is using an equation to figure out how much how much of this box can actually hold if you're going to fill it with water or fill it with gravel or something like that, right? What's the volume of this box? Okay, so we're going to be doing that though for pyramids and for cones now. Okay, so the volume for a right prism of any kind is going to be the area times the height. And what does that mean? It means the area of the base, right? So it's like the area down here times the height of our prism. Now, I think it's worth just talking about this for a second. If we used, well, let's use it on this one. Okay, so it's the same idea with a right rectangular prism. So you might remember the formula: volume is equal to length times width times height, right? So length times width times height. And in this example here, our length and our width, right? If I just multiply both of those two things together, well, that really would just be the area of the base, wouldn't it? And then one more thing to multiply by, we just multiply by the height. So even in this case, this was the area of the base, right? The area of the base times the height. It was the same thing. But we can think about it, you know, in this example, it would still just be the area of this hexagon and then times the height. And that's always going to be the case when we're looking for volumes. Just find the area, that area, and then multiply by however high it is. Okay. The area of a right pyramid, right? So if it comes up to an apex of some kind, well, that's actually going to be a third. So it's like you've gone straight up and down, but well, here, if you want to, why don't we like, you can kind of see it, right? So if I kind of drew lines from all of those up to the peak there, the area inside that pyramid that was created would just be a third of the entire area. So you could fit 3 more of those inside of that shape there, right? So I won't get into the proof of why that's the case, but that is the case. Yeah, so that's going to be our formula for that one. I talked about that already. And then again, the area for a right rectangular pyramid, just like from above, right, is 1/3 length times width times height, or 1/3 area of the base times height. Be the same thing, right? Or you might see it written this way too: length times width times height divided by 3. That's the same thing as multiplying by a third. All right, a right cylinder with a base R and height H will have this volume. And this is actually the same thing, isn't it? Because volume is equal to the area of the base times the height. Let's see if that makes sense. Well, the area of the base would be that circle. Okay, well, that's what this formula is saying, isn't it? The area of that circle is pi r squared, and then just times the height. So it's following the same pattern here, right? And then the volume of my cone would be the area of the circle, right? That's that part, times the height, but then it's going to be a third of that when we're done. Okay, so that's what's happening. Good news is you guys don't have to memorize these. These are on your formula sheet. So they're under volume here, right? So you have that for all those general shapes. Okay, so let's get into question 1. It says, calculate the volume of a right square pyramid with a base length of 4 feet and a slant height of 7 feet to the nearest cubic foot. So let's sketch this out. Perfect. Guess I shouldn't be happy about my own work, but I'm impressed with myself. So, so calculate the volume of this thing. It has a base length of 4 feet. So that's 4. And it's a right square pyramid, so that's also 4, right? Each side of that thing. And has a slant height of 7 feet. So a slant height of 7 feet. So that's going to be from here down to like there, let's say. Right down the face of that thing from the last lesson. And we want to find the volume. So let's write down, oh, I'm sorry, we'll write down 7, so we remind ourselves there. Okay, let's write down what the formula for a right square pyramid is. So on your formula sheet, you should see a right pyramid, right? And that is, the volume is 1/3 length times width times height. So let's write that down. So we're going to have 1/3, their volume is equal to 1/3 times length times width times height. Okay, so volume is equal to, and oh, we've run into a problem, haven't we? And the problem is really this height, because the length and the width, that's going to be 4 and that's going to be 4, but what's the height? Well, again, we're bringing trigonometry into this, because the height we're talking about when we're doing volume is the actual height of the pyramid. So we need that height up and down right there. Oop, come on. Okay, so this should look familiar from last lesson there. If I'm looking for h, and I have the hypotenuse of 7, well, what would the length of my bottom be? And maybe you guys are seeing this. If the length from here to here is 4, then it's going to be half of that, right? If this is coming down to the middle, so this would be 2. All right, so h squared is going to be equal to 7 squared minus 2 squared, right? And I'm subtracting because I have the hypotenuse. Okay, so it's 7 squared minus 2 squared is equal to h squared. Okay, so h squared is equal to 49 minus 4. So h squared is equal to 45. And then very last step, we're going to say h is equal to the square root of 45. And I'm just going to leave it like that because that's all of my decimals. I don't have to round anything in that case. Okay, so now we're pretty good to go. Now let's plug it in. So the volume is equal to 1/3 times, and then the length was 4. And then the width was also 4. And then the height was what I just found there, right? That's that square root of 45. I made it red so it reminds you where we got it. Okay, and then let's plug it all in. So V is equal to 1/3, so 1 divided by 3 times 4 times 4, and then times the square root of 45 is equal to 35.78. And it wants our answer to the nearest cubic foot, so that would just be rounding this up to the volume is equal to 36 feet cubed. And remember, yeah, when we're dealing with volume, we're using cubic feet, right? Not square. It was squared for surface area, and now it's to the power of 3 with our units. All right, number 2. Determine the volume of a right rectangular pyramid with base dimensions of 3.6 by 4.7 and a height of 6.9. Okay, so this one's actually going to be a little bit easier even, right? Because we've been given everything. They straight up gave us the height. So just plug it in. So the volume is equal to, yeah, I'll just write down the formula. Length times width times height. And it was 1/3, sorry, for a pyramid. So volume is equal to 1/3 times a length. And it doesn't really matter here, does it? Whether or not I call this the length and this the width, or this the width and this the length. Either way, it's the area of the base is what's happening there times the height. So I'm just going to call the length 3.6 and my width 4.7 and then my height 6.9. So if we plug that all in, we get 1/3 times 3.6 times 4.7 times 6.9. So 38.9. And then that's cubic meters. So meters cubed. Okay, so cones now. It says determine the volume of a cone with a diameter of 8 millimeters and a height of 13 millimeters to the nearest cubic meter. Okay, so a cone, we can sketch this out by drawing an oval and then just making it come to a peak. All right, not great, but good enough. So it says that the diameter is 8 millimeters, so let's go 8 from there to there, right? And they've given us a height of 13. Okay, so we're pretty good here. The one thing we're going to need to know is that instead of a diameter, the equation, when we grab it here for a cone, is 1/3 pi r squared, right? So we need r instead of the diameter, and then times h. All right, so this will be volume is equal to 1/3, and then pi r squared, and then times h. So the volume is equal to 1/3 pi times, and I like to put in brackets when I put a variable in. Now what do I put in for r? Just be careful here. It's not 8, right? It's going to be half of 8. We need the radius, so that'd be 4. So 4 from there to there, right? So that'd be 4 squared times 13. And then we'll just plug it all in. So 1/3 times pi times 4 squared, and then times 13 equals 217.8. And then what was that? So nearest cubic millimeter. So then that would actually be rounded to 218, right? And then that would be millimeters cubed. Okay, a cone has a height of 8 millimeters and a volume of 8 meters and a volume of 300 meters cubed. Determine the radius of the base of the cone to the nearest meter. Let's sketch it again. Okay, so it has a height of 8. So they're saying from here to here is 8. And they've given us a surface area, or not surface area, volume, sorry, of 300 meters cubed. And we're after the radius, right? So we're after from here to here, right? We want r. Okay, so where we start with this is we want to write down the formula. So let's see, the formula for a cone was 1/3 pi r squared times h. So step number 1, write that down. So volume is equal to 1/3 pi r squared times h. And now we're just after r. So we just have a little bit of algebra to do, don't we? Now, you can put your numbers in now, right? You could actually, put in 300 for v, and then, 8 for h, and then rearrange. But the other way you could do it, you could rearrange just with the values, right? So if you guys are, or with the variables, I mean. So if you guys are taking Science 10 right now, you will have been doing this, right, for your physics. Next year in Physics 20, where we do a ton of this. But, okay, anyway. For now, I'll just put the numbers in for now. So we'll say instead of 300 meters cubed, we're actually going to put that into here, right, because that is the volume. So we'll say 300 is equal to 1/3 times pi times r squared, and then instead of an h, I'm going to put in 8. All right, now let's think about what we're looking at here, right? I'm after r. We'll get r on its own in the end, right? And 1/3 pi, that's just a number, and then 8 is just a number, right? So I just got to get those two numbers over there, don't I? So this is just our inverse operation stuff. So if I want, let's do them one at a time just to make sure we're doing this right. If I want to get rid of that 1/3, how do I get rid of that? Now, you can do it. This one confuses kids sometimes when they're thinking, you know, 1/3, and I'm multiplying 1/3, so maybe I'll divide by 1/3. And actually, to tell you the truth, that would work. You could do that. It's just a little awkward going like 300 divided by 1/3. You get the right answer, but it's just, like I said, it's not a very nice way to think about it. What I'm going to do here is I'm going to get rid of this 3 by multiplying both sides by 3. Right? Because if you think about this, now I've got 3 over 3, and the 1's still there, but that's fine. I want to cancel that anyway, right? So I'm going to multiply both sides by 3. Okay? So that will be, so when you plug that in, 3 times 300 is going to be 900 now, is equal to, and then, look, this is gone now, right? So now all I'm left with is pi r squared times 8. And you know what? Typically, I'm going to write it this way, as 8 times pi r squared. We don't usually write the number on the end. We like the number being out front, but either way, doesn't really matter. Okay, so now that I'm looking at this, right, I could divide by just 8 and bring it over, and then divide by pi and bring it over. But you know what? This one's set up kind of nice. Why don't we just get rid of that 8 pi all as one thing? So I'm going to divide both sides by 8 pi. So those cancel. I'm going to divide this by 8 pi. Okay? And now we can actually put it into our calculator if you like. But actually, you know what? I'm going to leave it that way for one more second. Let's keep going. So now what we have left is 900 divided by 8 pi is equal to r squared. Very last thing we got to do, right? If this is all equal to r squared, why don't we take the square root of both sides? Right? So those will cancel, and we'll get r is equal to the square root of 900 over 8 pi. Now, to tell you the truth, when we do this, what's going to happen is that we're going to round it, right? Because of, well, taking the square root and the pi, we're going to get an irrational number here, right? So this actually would be the most accurate way to leave your answer. You just leave it just like that. You wouldn't even have to put it in. But they want us to determine the radius to the nearest meter, right? So we can actually just plug it in and see what we get out. So here, so let's plug it in. So we're going to go, and we could plug it all in with square root and all, but tell you the truth, just so we kind of get used to doing piece by piece here, I'm going to do the inside, and then I'm going to take the square root of that. Okay, so I'm going to go 900 divided by, now careful here, I'm going to show you what not to do. 900 divided by 8, and then if you go times pi, this is going to give me the wrong answer. 900 divided by 8 times pi. And I want to show you why that's going to give me the wrong answer. Because if I just type in my calculator 900 divided by 8 times pi, what it thinks I mean is 900 divided by 8 and then times pi. Right? It does this one first and then takes that and multiplies it by pi. We need a way of telling the calculator that we want that pi to sit in the bottom there. Okay? And the way we tell a calculator to do that is to put that in brackets. Okay, so now it knows the 8 pi is in the denominator. Okay, so when we did this, we should have went 900 divided by 8, divided by, and then in brackets, 8 times pi. You can write 8 pi or 8 times pi, it knows what you mean. So 8 times pi, and then that's good. It knows that that's in the denominator now, right? So now if I push enter, that's what it's equal to, right? But then just remember, we still have to take the square root. So what I'm going to do is just go, okay, square root, and then either go up and grab it or go second answer, right? And that grabs my answer from above. Okay, so it's equal to that. Now, you could have done all that in one move too, so I'll do that really quick. You could have also done it like this, where it was the square root of 900 divided by, and then see I'm still all underneath the square root now, and then in brackets 8 times pi or 8 pi, and then close my bracket. Okay, that would have done it all in one move, and if you're feeling bold, you can do that too, but you see I get the same answer, right? So 5.98, and it wanted it to the nearest cubic meter, right? So 5.98 would just round up to here. 5.98 would round up to 6 meters cubed. Or, no, sorry, meters, not cubic meters. Just 6 meters is equal to R.